Hello friends, in this video we are going to study the direct deflection method which is used for the measurement of high resistances. High resistances are those resistances which are of the order greater than 100 kilo ohms to several mega ohms. So here we will study the direct deflection method which is used for the measurement of such high resistances. So let us start with our topic. Said that high resistances are those resistances which are greater than 100 kilo ohms. Okay, so we can say that resistance values greater than 100 kilo ohms, or we can say zero point 0.1 mega ohm, they are termed as the high resistances. Now, there are various examples of high resistances like the insulation resistance of the electrical equipments, okay, volume resistivity, surface resistivity of the equipments. So, all these resistances, they come under the category of high resistances. So, let us see some examples of high resistance. So the various electrical equipments, they are coated with an insulating material so that no current is flowed in that. Okay, or no damage is being done to the equipment. So to protect those instruments, we have an insulation coating over it, and that insulation coating will have some resistance. So this resistance, it is of very high value. So that comes under the category of high resistances. So one example is the insulation resistance of the components and built up electrical equipments like machines and cables. In cables also we see that inside we have the wires which carry the current or the voltages. Okay, over that we have coating of different materials. Okay, so the outermost material, which is the insulating material, insulating material is that material which do not allow the current to flow through it. Okay, so though there is no leakage of the current through that insulating material, so that insulating material will have a very high value of the resistance. Okay, second example, resistances of the high resistance circuit elements like in vacuum tube. In vacuum tube also the resistance of the circuit element is very high. Okay, that is also of the order of mega ohms. So these are all the examples of the high resistances. First is the insulation resistance of machines and cables, then resistances of the high circuit elements like in vacuum tubes, then leakage resistances of the capacitors, volume resistivity and surface resistivity of a material. Okay. Now, in the measurement of these high resistances, there are various difficulties which are faced. So, let us study some these difficulties so that we can further study the method and how that method has clarified those difficulties. Okay. Now, first difficulty in the measurement of high resistance is that we are in high resistances, what we are measuring, the insulating resistance. Now, this insulating resistance is comparable to the value of the resistance which we want to measure. So, as the two resistances, they are of the same value, so leakage currents are produced in the circuits, and these leakage currents, they can affect the value of the unknown resistance which we want to measure. Okay, so first difficulty is insulation resistance. So the high resistances, they are coated with an insulating material, and that insulating material will also have a resistance which is called the insulation resistance. Now this insulation resistance is comparable to the value of the actual resistor which we want to measure. Now if we are using some method to measure the value of that resistance, so insulation resistance and actual resistor, they are of the same value, so leakage current is produced. Leakage currents are those currents which are flowing in any part of the machine. Like suppose for the current we have a particular path, and instead of that path, if the current is flowing through some other parts of the machine, then that is called the leakage current. Okay, means the current which is leaked through the wire. Now because insulation resistance and the actual resistor, they are of same value, so leakage current will be produced, and the ammeter which is connected in the circuit, it is going to measure the current, and because that current will be the leakage current also, and the current flowing through the resistor also. So the value of the measuring current and the measuring resistance, both will be affected due to this problem. Okay, so that is the first difficulty which is faced in the measurement of high resistances. Now, second difficulty is, now as the value of the resistance which we are measuring, it is very high. Okay, so due to that high resistance, electrostatic effect will be generated, and due to that electrostatic effects, the changes can appear in the measuring circuit, and those changes can affect the value of the measuring resistance. Okay. Now, insulation resistance of the high resistances, that can be represented as a resistor and a capacitor which are connected in parallel with each other. So, if we are representing the insulation resistance, it will be like a resistor and a capacitor which are connected in parallel with each other. Now, when the ammeter is connected to measure the current, and when we are measuring the actual resistance, suppose here we have connected a resistance which we want to measure. Okay, now this resistance value will be the sum of the resistance value due to this insulation resistor, and also due to this capacitor, and also the current if we want to measure, then that current will be the sum of the current through this resistor and through the capacitor. So the measuring value of the current and the resistance, both will be affected due to this insulation resistor. It will have both the capacitive part also and the resistive part also. So because the current, it is including both the capacitive and the resistive component, so true value of the resistance cannot be obtained. We will have errors due to this insulation resistance. Now, there are other factors also which can affect the value of the resistance which we want to measure, like temperature. Temperature can also change the resistance, humidity, the kind of current which we are employing, either it is AC or DC, and whether the current it is constant or fluctuating. Okay. And also the duration of the applied voltage. Suppose we have applied the voltage for a longer period of time, so that is going to damage the delicate instruments of the circuit. So the duration of the applied voltage, it also affects the value of the measured resistance. So these are all the difficulties which we face when we are measuring the high resistances. Now, how these difficulties are removed? These difficulties can be removed with the use of a guard circuit. This guard circuit, it prevents the leakage currents to be measured. If we have provided a guard circuit in the instrument, then the leakage currents, they are going to bypass through this guard circuit, and the ammeter, it will measure the correct value of the current, and also the value of the resistance can be correctly measured. So let's see that how the use of that guard circuit eliminates the leakage currents. So the concept of the guard circuit is to bypass the leakage current from the ammeter, so that the ammeter, it measures only the true value of the resistive current, and because if we have the correct value of the current, then we are going to measure the correct value of the resistance also. So this guard circuit, it bypasses the leakage current. Now let's see two circuits. In one circuit, no guard circuit is present, and in another circuit, guard circuit is present in that. So let's see that what will be the effect of this guard circuit. Now these are the two circuits. In one circuit, no guard. This is without the guard circuit, and this is with guard circuit. So as I've said that in the guard circuit, what is done? The leakage currents, they are bypassed. Now when the guard circuit is not present, this is the insulation which is provided to the high resistance which we want to measure. R is the high resistance, or we can say the unknown resistance which we want to measure. Now to measure this unknown resistance, we have a voltmeter which is measuring the voltage across this resistance, and we have an ammeter which is measuring the current. Now voltmeter, it is correctly measuring the correct voltage, but ammeter, it is measuring both the resistive part plus the leakage current. So IR, that is the current across the resistance, plus IL, that is the leakage current. Now this current is due to this insulation which is provided to the high resistance. This insulation is also having some kind of resistance value, okay, and this current, it will also pass through it. Okay, now if guard circuit is present, then a wire is connected here across this insulation, and this wire, what this wire does, it is going to bypass the leakage currents through this guard wire. Okay, and the ammeter, it is going to measure only the correct value of the current, or only the resistive current, that is the current which is passing through the high resistance. So here we are getting the true value of the measuring current, and here we are getting the true value of the voltage. So by voltage and current readings, we can easily measure the resistance. Okay, so this is the concept of the guard circuit. The guard wire which is connected across it, it is going to short circuit this connection. Okay, and it is going to bypass the leakage currents. Now let's study the direct deflection method, which uses this guard wire concept for the measurement of high resistances. The direct deflection method, it is used for the measurement of insulation resistance of the cables. So let's see the circuit for this direct deflection method. In this direct deflection method, we are measuring the insulation resistance of a cable which is having a metallic sheath over here. So here we will have that metallic sheath. In that we will have that insulating material, and inside we will have the conductor. So in cables, what we have, the inside part is the conductor. Over the conductor we have an insulating material, and over that insulating material we are having a metallic sheath. So here this method is used for measuring the resistance of the cable which is having metallic sheath over here. Now on the conductor we have the wire. So this is the circuit which is for the direct deflection method. In this you can see this is our metallic sheath. This is the insulating material, and this is the conductor. So through the conductor, we want to measure the resistance of this conductor. So here we have connected a galvanometer which is measuring the current. Okay, and here guard wire is connected over the insulating material. Now due to this insulating material, we will have the leakage currents. So this guard wire is doing, it is bypassing the leakage currents through it. So when this switch is connected, the IR current, it will be short circuited, means this galvanometer will be short circuit and all the current will flow through this closed path. Okay, now when this is open, it means the current is flowing through the galvanometer will measure the IR current. Okay, so voltmeter is giving us the voltage readings, galvanometer is giving us the current readings. So through that we can measure the resistance in it. So the leakage current, you can see here the galvanometer measures the current between the conductor and the metallic sheath, and the guard wire, it is bypassing the leakage currents. So that was the case when the cables, they are having a metallic sheath over it. Now the second case is of the cables which are having no metallic sheath over there. So the cables which are without the metallic sheath, we can measure the resistance of those cables by the same way in which we are measuring for the cables with the metallic sheath, means guard wire is used. Okay, that guard wire is surrounded across that insulating material. Okay, and the galvanometer is connected, and that galvanometer is going to measure the current through the conductor. Voltmeter is used to measure the voltage, except the difference is that the ends on which the connections are made and the ends which are without the metallic sheath, they are immersed in the water. Now here the water is acting as the circuit part, and it is used to complete the circuit. Okay, to complete the flow of the current through that circuit. So let's see the diagram for it. Now this is the metallic sheath which is immersed in the water. Now this cable, it is not having a metallic sheath over it, so this is the complete cable. Now in this cable we have the insulating material, and inside that we are having the conductor. Now we are measuring the resistance of the conductor, and leakage current is produced in the insulating material. Guard wire, this is the guard wire which is wounded around the insulating material, so that the leakage currents produced, they will be bypassed through this guard wire. Now cable, it is not having a metallic sheath over it, so the current which is flowing in the circuit, that current will be flowing through this cable and then through the water. So this is the water, this is the tank. So tank and water, they are forming the closed path for the current. Okay, you can see here that one part of the voltmeter, one wire is immersed in the water directly, so the current will flow through the water and then through the voltmeter. So in this way the circuit will be completed. Okay, first time the galvanometer, it is going to measure the resistance current, the current across this conductor, and the voltmeter, it is going to measure the voltage across it. So the unknown resistance of the cable, so the resistance of the cable is given by the formula R equals to V by IR. IR is the current through this galvanometer, and V is the voltage reading from the voltmeter. Okay, so here we have studied the direct deflection method. Both the cases we have considered. First case was when the cable is surrounded with a metallic sheath, and second case when the cable is not having a metallic sheath over it. Okay, now when the cable is not having metallic sheath, we are immersing the cable into the water. Now this water is a saline water. Okay, and this saline water is kept for 24 hours at a temperature of 20 degrees Celsius. 24 hours for 20 degrees Celsius. So temperature is kept at constant, and the salinity of the water is also kept constant. So due to these factors, there will be no change in the resistance. Okay, the resistance will not be affected due to these factors. So in this video we studied about the direct deflection method, which is used for the measurement of high resistances which are greater than 100 kilo ohm or 0.1 mega ohm. We also studied some of the examples of high resistances. Then we saw the difficulties which are faced when the measurement of high resistances is done. Then we used that what is the use of the guard circuit, which is used for bypassing the leakage current. And in the last we studied the direct deflection method, two ways: one in which the cable without the metallic sheath, one in which the resistance of the cable which is with the metallic sheath, it is measured. So I hope that this topic, measurement of high resistance using direct deflection method, is clear to you. Thank you.